Welcome back to Energy Conversion System 1. In this video, we will talk about energy outlook. Before going into the detail of the energy outlook, we need to look back at some fundamental understandings of the energy. Maybe recalling back the memories from the thermodynamic class, a simple question as what is energy? The easiest way to find the answer is by looking at a dictionary probably, and we can find from any dictionaries that they will give us an answer that called as energy is the ability to do work. And now we have another term called as work. In the same dictionary, we might also find the definition of work as the energy that being transferred by force, or mathematically we can note it down as work equal to force multiplied with displacement. A simple explanation would be that we have a box with a mass of m and we want to move it as far as d, and to move this box to a distance of d we need to apply a force. So that's the easiest way to understand the correlations between energy and work. Energy itself exists in several forms. First one, the thermal energy. Also we have mechanical energy, and then we have kinetic energy. We also have potential energy. We have electric, and we also have magnetic and chemical energy. And the sum of all of this type of energy called as total energy. From the thermodynamics course, we also understand that energy is neither created nor destroyed in any normal physical or chemical process. The energy itself merely changes from one form to another form of energy. Means that it cannot be destroyed, it can only be converted to other form, or in a simple way we call them as the law of conservation of energy. Thus, we can say that the total amount of energy will remain constant during the process, and a loss of energy by a system during any process will be equal to the amount of energy gained by the system surrounding or the environment. Let's say that this is a box of a system and we have the environment or surrounding here. So whether we are giving work to the system or the system releasing, for example, energy in a form of heat to the environment, the amount of energy will remain constant throughout the process. So that we go back to the conservations of energy. These terms, we know it as the first law of thermodynamics. From the conservations of energy, we understand that energy cannot be destroyed or it cannot be created. It remains constant in a whole system. So, however, we understand that energy can change from one form to the other form through energy conversions. Therefore, for example, we take, let's say that we have an energy sources. These energy sources can be converted into mechanical energy, and this mechanical energy can also be converted into electrical energy. Let's say the one that we have in hydropower turbine, for example, where we have water as the energy source that turns the turbines, and the turbines turns the generator, and then we get electricity as the output. Another form of energy that we know is the thermal energy. Let's say the source of thermal energy, we have energy source for thermal energy, let's say the fossil fuel, coal, petrol, diesel, and so on. Then they are being converted to the thermal energy. Then we have heat now. This heat can be turned into, let's say in a gas turbine, for example. We can use gas turbine in a combustor that generates heat, and it can also turn or rotate a turbine blades. Then we have mechanical energy. From this mechanical energy, it will also be used or connected to a generator, electric generator. And then at the end we have electrical energy. On the other hand, the thermal energy can also directly be converted to electrical energy here through a process called Thermoelectric. Yeah, this consists of some electronics here, devices that convert when we have a thermal energy, and then we can get electricity out of it. So it's called thermoelectric effect or Peltier effect or something. The energy sources can also be converted directly into electricity. For example, when we have solar power plant, when we have this PV solar collector, then it can be converted directly through the electricity. On the other hand, the conversion from mechanical energy to thermal energy is also possible through frictions. And for example, when we also have electrical energy, it can also be converted back to mechanical energy. For example, the one that we have in electric cars, where the electric motor is being used to move the tires of the car, and then it replaces the combustion engine, but yeah, it's still converting the electrical energy into mechanical energy and turns the car or moves the car.